In this slide deck, I'm going to talk about single row functions. So these are functions that you could run against a single value. So they're not aggregated or categorized or anything like that. We'll talk about those more later on. Those are generally called group functions. So when we talk about single row functions, there's generally something that we include in either a select or a where clause. So we can, we can do something with a value, right? So it's a function that it provides some behavior, right? It does something with the value that we pass in that's an argument. So an argument is something that we're passing to that function. We're saying, hey, function, go and do something, and this is what you're going to do it with, right? And here's some additional arguments or things that we're going to tell you to do with it, right? And you're going to see some examples here as we do this. This is a simple example. If we have a select statement where we're looking for the ID number, the last name, and the first name from a table called Computer Pioneers, and we get a list, right, of a very simple list of people. So what are some things we can do with this? Well, first, I can use the upper. So most database engines have, and by the way, these functions can vary between different database engines. The SQL standards indicate there are certain functions that almost all database engines should support, but there are lots of additional functions that you can find within the database engine, and you can write your own functions. And we'll talk about that later on, how that works. So next week, I'll talk a little bit about how you could write your own functions to do something. If you want to add your own functionality to a database. Maybe there's different operations you're frequently doing that you want to put together and just make a single function call for that. And I'll show how to do that. There's also this concept of stored procedures, which is a little bit different. We'll talk about that as well and what that is. But in any event, in this case, upper is a pretty standard function that most database engines will do that will just convert whatever you pass in to all uppercase. So now that select statement, instead of being mixed case, everything's going to be returned as uppercase. And you could also make it all lowercase if you want, right? So just like it could be all upper, it could be all lower. And then init cap is nice if you want to show the like a name in the right format, right? It'll make sure that the first character on each one is capitalized. So in this example, the first and the last name both have the capital on it, which is how we usually expect to see names. All right, so if we've got our names formatted well from our select statement. So in our where clause, I might convert the last name to all uppercase. That way I don't have to worry about what case I'm querying for, because as I mentioned in other videos, a lot of database engines are case sensitive, meaning that they don't consider all cases the same, right? So an uppercase B is different from a lowercase b, and they won't equal each other, right? If you're doing if you're doing some logic. Another character-based function is a substring, which lets you return only part of a string. In this example, the word hello is the first 5 characters, then I have a space, and then starting with the 7th character is the word world. So if I only wanted to get the word world in this example, I would want to begin at the 6th character and end at the 5th character. I can count 5 characters, so I'm going to start at 6 and count 5. So as another example, let's say I wanted to only return Drexel in my email address, right? So I would use substring and start at character 7, and then count 6 characters to get the word Drexel, and it'll only return that part of the email. But I could use instring. So instring will tell me the character at which the @ symbol occurs. So instead of hard coding to start at character 7, I'll say start at whichever character has the @ symbol and then count 6. And I could even get even more fancy, right? And I could say add 1, so it starts at the D instead of the @ symbol, and count 6. And I could also tell it to end when it gets to the period and subtract the 2, right? So it's more dynamic. So this will always return the first portion of that domain using the substring function. So I combine 2 functions here. I combine the instring, which returns the character or the position at that character, and also the substring, and put it all together to kind of dynamically extract just a certain portion of that substring. This arguably could be easier to do with regular expressions, though, which we'll talk about in a little bit. All right, and of course we have to do a little bit of shifting around to get exactly what we want, right? We don't want to go to the period, we want to go 1 character before the period, right? So we're going to subtract 1 from that so we get the right position, and then it returns just Drexel. And then it'll work with just about any other string, right? Any other string that's an email, it'll figure that out. The length character function returns the length of a string. So for example, if I select the last name and first name with the length function, it's just going to return integers, which will be the length of those characters. So my name would be 5 and 5, right? Brian, and green is 5 and 5. The padding, you can add padding. So in this case, if I L-pad a string, that means put a pad on the left side. It can add characters. So for example, maybe I want to add zeros to the front of the ID. So I can pad the front of the ID with 9 zeros in this example. So now my IDs look a little bit more like, I guess it makes it look like we have more stuff in our database when you add zeros, right? People assume that if you have all those zeros, that means that you're using them somewhere, right, for real numbers. So that's an example. You can also do a trim, right? So I can trim off those zeros if I want. I can say if there are leading zeros, they're kind of confusing. So trim, use left trim to trim off all those leading zeros. By default, if you do trim without an argument, so that second argument is an overload, meaning you don't necessarily have to provide it. And if you don't provide that argument, it'll just trim white space. So that would be carriage returns, spaces, line feeds, anything that's white space. Any characters that you can't see will be trimmed off from that string. Replace will allow you to replace a character. So for example, this is a phone number. I could replace all of the dashes with an empty string, meaning just take the dashes out, right? I could put something else there if I could put forward slashes if I wanted to, or a solidus. So if I run that command, what I'll end up with is just the phone numbers without the dashes. You can concatenate strings together, right? So here I have my last name and my first name. Instead of showing them as different columns, I can combine them into one column. Doesn't look very nice, so you can concatenate a blank space and a comma as well. That way it's a nice formatted first and last name. So that's the concat function. And again, most database engines have some analog to concat. They may have slightly different syntax for how to concatenate. Some database engines let you do it in line with a plus or with a pipe symbol, but this is kind of the official SQL 99 way to do it. We've got lots of functions we can use for numbers as well, right? So for any numeric data like a float or an integer, decimal, and so forth, if those are the data types, you can use the numeric. So for example, we can round a number to a certain number of places. So as an example, and these are the places, this is Oracle syntax, but it works in MariaDB as well. But different database engines have slightly different syntax. It's important to look up the, you can go online and you can search for the syntax for these different functions in different database engines. But as an example, let's say I just want to get everything to the left of the decimal point. That's going to be 0, right? So 0 is going to be basically the whole number without any decimals. And it's going to round it for me so that 1928 becomes 1929 with no decimal points. If I go to -1, it's going to go one position north of that, so it rounds it up to 1930. And I can go even one more position, and it'll round it up to 1900 if I do -2. I can also go the other way. So for example, I can round it to the first decimal place, so that'll be 0.9. I can go to the second decimal place, so that'll become 1928.2. Truncate is very similar to round, except it just chops off instead of rounding up or rounding down. So it'll just chop off that value. So as an example, and again, it uses the same syntax. If I chop it off at the 0, I get 1928. If I chop it off at the 2, I get 1920. If I chop it off, 1900. If I chop it off at the 1, I get 1928.9. And again, with 2, it's not going to change it to a 2. It's going to keep it as a 1 because we're just chopping off those values. So to the right of the decimal, it chops it off. To the left, it's just gonna keep that number and change everything else to zeros, right? So that's what truncate does for us. Absolute values will, if you have a negative value, when you use absolute or ABS for absolute, it's just going to convert it to a positive integer, right? The absolute value just doesn't have a sign. It's not negative or positive. You can also use power, right? You could take the power of a number, so x to the power of y. So for example, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so forth and so on, right? 2 to the power of 3, which is 8, and keep going if you wanted to, right? Dates have some special functions. Dates are kind of neat because the database engine automatically knows how to handle dates for you, right? You don't have to figure out how to do math for dates. You don't have to understand the calendar to do all that. It does it all. It's all built into the database engine. So we can work with dates with special date functions. Different database engines have different date functions that you can work with. So for example, I can select all the months between date 1 and date 2, right? And then it'll show me or how many months rather. So it'll take date 1 and date 2, it'll calculate how many months are between those dates, and it'll return an integer, which is the count on the number of days. So in this case, it's -34 because one date is before the other. I'm saying how many months do I have to go to get from December of 1999 to October of 2002, and it's -34. Um, so likewise, sorry, a couple different ways to do this. You can also get a if you put a specific date in, it will give you a decimal, right? If you use a specific date, we can add months. So if I have a date, and let's say I want to add 8 months to it, right? So I have 31 October 12. What is that date in 8 months from now? It's 30 June 13, right? So it figures that out for me. It knows that there's only 30 days in June, so there's no June 31st. It knows not to just add October to June, right? It knows that you have to drop that date by one to make it a valid date, because again, it understands the calendar. You can say what's the next day, right? So, for example, I have a date of June 1st, 2013. I can say, show me the next date that's going to be a Thursday, and it'll return the next date on a Thursday, right? So again, lots of little things you can do. What's the last day of the week? So if I'm in, 2 February 12, what's the next day? And so forth and so on. So all kinds. And by the way, sometimes it's not as obvious, right? So if I have 29th February 2012, the next day, um, uh, sorry, February sometimes has 28 days and sometimes has 29 days, right? So it understands the leap years, and you don't have to worry about how to calculate all that stuff. You can also, generally, most database engines have different mechanisms for formatting dates. So you can show how you can determine how it's going to store a date or show a date based on what formatting you want. So there's usually functions that'll let you pick what kind of date you're going to display, and I'll show you some examples of that specific to MariaDB when we look at how to do the lab. So you would look up, the syntax to show dates in different formats to make them readable. Um, all right, you can also round dates, right? So, for example, I can round to the nearest year, I can round to the nearest month, and so forth and so on. Regular expressions are supported in most database engines. For example, what can you do with a regular expression? I don't want to teach you how to do regex because I could do 5 whole PowerPoint decks on how to do regex. It's almost a whole programming language unto itself, but it's pretty powerful because it allows you to look for patterns in text and pick out patterns to do things. So for example, I've got this little blurb of text. I could write a regular expression that extracts only email addresses from this text. So if I'm looking for email addresses, I can pick them out, right? It can be a little bit complicated because, the @ symbol appears in here, the dot symbol appears in here, but it has to be a certain pattern of characters with the @ symbol and the dot in order for me to consider it a valid email address, right? And try to pick it out of these sentences. So regular expressions would allow me to do that. I can look for the @ signs. I could look for the dots that are contiguous to the @ signs. I have to make sure I strip the ones that are on the end of sentences and ignore the ones that aren't part of an email address. And try to use this, look for these patterns to come up with something that gives me an email address. It turns out that what you see here is the regular expression you would use to just find email addresses in text. And this would work in Oracle. This would also work in MariaDB with its regular expression processor. And again, the thing about regular expressions is when you do a select with regular expressions, basically all this is going to do is find any record that contains an email address in that blob of text, but you could also use it in the select so that you're only getting email addresses in your select. So just select for me all the email addresses that appear in a blob of text or in a text field in my database. You could do that with and here's an example, right? So that's going to return just the email addresses. Since there are multiple email addresses in each blob, it has to return it as multiple records, right? So you're going to get multiple rows from that statement. It's important to understand that even though these are row functions, you could get multiple rows when you select it. So it gets a little bit complicated. In different database engines, it's going to be handled in different ways. Sometimes you have to write a function that iterates through it. There's different things that could happen. But again, it's important to understand that you can do some really cool stuff with regular expressions, and most database engines have some regular expression functionality built in. And you can use regular expressions in your SQL queries, either in the where clause or in the select clause. There are also a whole bunch of other functions. There are special functions with null, so you can how you handle null values. You can say if a value is null, return a different static value, for example. You can convert different formats from one format to another, for example, a character to a date or a date to a character. Um, You can do if then else logic right in your select statement. So if a column has a certain value, then display a different value, otherwise display this other value, right? So just, basic programming, you can do some if then else logic. It can get, again, it gets a little complicated. I don't want to give you too many examples around that. I just want you to understand that you can do that sort of thing. Another interesting one is Soundex. This is in both MariaDB and Oracle, and also Microsoft does this too. Microsoft SQL Server. I don't know if Sybase does it or not, but again, a lot of the databases do this where instead of looking for values based on how they're the character values, instead it will do it based on how they sound, right? So think about let's say you're looking for a customer whose last name is Smith, Smith. So let's say that the user puts in Smith. Well, what if there's a Smith that's spelled Smyth, right? They're pronounced nearly identical, but they're spelled completely different. They have different letters, so the database engine wouldn't be smart enough to figure that out. But if you use Soundex instead, Soundex will take how the word sounds and look for any other words that have a similar sound. So it's kind of neat that you can do that, and there's some interesting examples where you can do that. I've done this. I work with with systems that are generally working with patient records. And sometimes we'll use Soundex to try to find matching patients that have similar sounding names. So Soundex is kind of an interesting feature that a lot of database engines have. And there are tons of other functions. If you look at the documentation for whichever database engine you're using, be it MariaDB, MySQL, Microsoft SQL Server, Sybase, IBM's database engine DB2, or PostGre or whatever, they all have built-in functions that you can work with, that you can use. And if you're looking to solve some problem, as you're doing a select statement or where clauses, chances are there's probably a function that can help you if you need a function. And again, if you can find a function that does what you need it to do, you can always write your own. And we'll talk about that in a different slide deck.